to the program. My name is Sarah Makibino, and today we'll be looking at quadratic equation using the method of completing the square. Well, quadratic equation is a trinomial that is usually solved by factorization, but the aspect of quadratic equation that is not able to factor is being solved using the method of completing the square. Now, quadratic equation comes up in this form: ax squared plus bx plus c is equal to 0. This is the general formula. You say this is the general formula for quadratic equation. So an equation that comes up in this format is a quadratic equation. An example would be 3x squared plus 2x minus 3 is equal to 0. Now, as long as the format is arranged this way, the s square comes first, then the x, and a constant, and everything equates 0. It is a quadratic equation. This is a quadratic equation. Now, we said the aspect of quadratic equation that is not able to be solved using factorization method is usually solved using method of completing the square, and the quadratic formula, which we call the almighty formula, well, aka almighty formula. Well, the almighty formula is actually derived from the method of completing the square, so it's very important for you to know how to solve quadratic equation using method of completing the square. Now, I'll just go over to a few steps that we have to follow whenever we are solving problems relating to completing the square. Step 1 will be to reduce the leading coefficient to 1. Reduce the leading coefficient to 1. That's step 1. So if I have ax squared plus bx plus c is equal to 0, how do I reduce this leading coefficient to 1? It's just by dividing it by the leading coefficient a, which is the whole of this. So I'm going to have x squared, okay, plus b over a x plus c over a is equal to 0. So this is what I'll have. So the leading coefficient here is now 1. Step 2 will be to equate the variable to the constant value of the variable. What that simply means is now we are having x squared plus b over a x plus c over a is equal to 0. The constant is this little man here that does not have x in it, doesn't have x variable at all, so it's a constant for the equation. The variable talks about the whole of this, okay. Our intention is to equate the variable to the constant, so this is called variables, variable functions, and this is constants. So this is the constant and this is the variable function. So our plan here is to equate the variable to the constant. So we will have x squared plus b over a x is equal to, if this cross is equal to, you have minus c over a. So that is exactly what you're having. That is for step 2. Then we'll move on to step 3. Step 3 says make the variable function a perfect square. So we're going to make the variable function a perfect square. Already what we are having is this x square plus b over ax is equal to minus c. Now this is the manipulation you do. This middle coefficient, that's the coefficient of the term x, okay, you divide it by 2 and square it, so it becomes b over a divided by 2, okay, or square. Now this is the value that should be added to this thing to make it a perfect square. So this can be written as b over a times 1 over 2, that's if we call this over 1, alright, all raised to the power of 2, which is b over 2a all raised to the power of 2. So this is the value that should be added to the variable to make it a perfect square. Now sometimes you get questions that says what must be added to the quadratic equation to make it a perfect square. This is the manipulation you do there, so you take note of this. Alright, now when we add it up, we're going to have a perfect square becomes x square plus b over a x plus b over 2a all raised to the power of 2, okay, is equal to minus c plus b over 2a all raised to the power of 2. Remember, whatever you add to your right hand side, you must add to your left hand side. So we're adding this to our left hand side, we must add it also to our right hand side to make the equation balance. And that is the same as having x plus b over 2a all raised to the power of 2. If you factorize this, this is exactly what you're going to get, is equal to minus c plus b over 2a all raised to the power of 2. Now this is the perfect square. This is what they call the perfect square formula. This is now a perfect square. I have square. I will have open bracket x square plus b over 2a all raised to the power of 2 is equal to minus c over a plus b square over 4a square. That's if I assign the square to every of the parts here. So this is going to give me x plus b over 2a all square is equal to, if I find the LCM of this, let me make it a common fraction, 4a square will be the LCM. 4a into this is going to give me 4a times c minus 4ac. Therefore 8 into this is 1 times this will give us b square. So here I'm going to have x plus b over 2a is equal to square root, because when the square cross is equal to, it becomes plus or minus square root of minus 4ac plus b square all over 4a square. So this will become, sorry, the square here cancels. Okay, this one goes out, sorry about that. So here I'm going to have x plus b over 2a is equal to plus or minus, if I rearrange this, I'll have b square minus 4ac all over square root of 4a square. this would become x plus b over 2a is equal to plus or minus square root of b square minus 4ac, everything divided by square root of 4 is 2 times square root of a square is a, so everything goes over 2a. Now if I take this across equal to, I'll have x is equal to minus b over 2a plus or minus square root of b square minus 4ac over 2a. So I'll take a common base here, which is 2a. Now becomes minus b plus or minus square root of b square minus 4ac. Now this is the value for x, and this is what you call your almighty formula. X is equal to minus b plus or minus square root of b square minus 4ac over 2a. So you call this the almighty formula. Alright, we'll just take an example here that says solve the quadratic equation using method of completing the square. An equation is given as 2x squared minus 3x minus 5. Now we'll just apply this step 1 to reduce the leading coefficient to 1. So you have 2x squared minus 3x minus 5 is equal to 0. Now if I divide all through by 2, which is the leading coefficient, I'm going to have this cancel out this. I'm going to have x squared, okay, minus 3 over 2x minus 5 over 2 is equal to 0. Then I'll go step 2 to equate the variables to the constants. So this becomes x squared minus 3 over 2x is equal to plus 5 over 2. So this is my new equation. Then if I go step 3, I would have what is that number that should be added to the variable to make it a perfect square? All I just need to do is to pick the coefficient of the x, divide it by 2, then square it. So this is giving me minus 3 over 2 times 1 over 2 all square, and that is equal to minus 3 over 4 all square. And when I put it into the equation, I'll have x squared minus 3 over 2x plus minus 3 over 4 all square is equal to 5 over 2 plus minus 3 over 4 all square. Take note, I'm adding the new value I'm introducing to make it a perfect square into both sides, both the left hand side and the right hand side. Then we'll proceed by solving this. If you have a pen you've taken down, we'll just wipe this off so that we can actually solve more of what we're doing here. This is going to be equal to x minus 3 over 4 all raised to the power of 2 is equal to 5 over 2 plus square of minus 3 will be 9 over 16. So here we'll have x minus 3 over 4 all raised to a power 2 is equal to what's the LCM here? 16 into 2 8 times this 40 plus 16 into 16 times 1 9. So here I will have x minus 3 over 4 all square is equal to 49 over 16. Alright, I'll just wipe here off again and proceed. We will now have x minus 3 over 4 is equal to square root of 49 over 16, and that will become x minus 3 over 4. Remember, your square root will have positive or negative sign. X minus 3 over 4 will be equal to square root of 49 is plus or minus 7 over 4. So this becomes x is equal to 3 over 4 plus or minus 7 over 4. The reason is because if minus 3 over 4 crosses equal to becomes plus 3 over 4, then we'll have x to be equal to 3 plus 7 over 4 or 3 minus 7 over 4. In both cases, you are having 10 over 4 or minus 4 over 4, and that will give us 2.5 or minus 1. So that's our final answer, 2.5 or minus 1. Another example would be to solve 5x squared minus 7x plus 3 using the method of computing the square. Now you take note here that the quadratic equation 5x squared is equal to 7x plus 3 is not yet in the quadratic form. So we have to arrange this by arranging it into a quadratic form, which becomes 5x squared minus 7x minus 3 is equal to 0. So this is the standard form for quadratic equation. What we did here was to take plus 7x across equal to and became minus 7x. Then you take plus 3 across equal to became minus 3. So we are going to start solving now. Step 1 is to reduce the leading coefficient to 1. So it becomes 5x squared minus 7x minus 3 is equal to 0 by dividing all through by 5 and also divide the right hand side by 5. So this becomes x squared, because 5 will cancel out 5, minus 7 over 5x minus 3 over 5 is equal to 0 still. So step 2 is to equate the variable to the constant. So we have x squared minus 7 over 5x is equal to 3 over 5, because when minus this crosses equal to becomes plus 3 over 5. Then I'm having here step 3, which means to find the number that must be added to the variable to make it a perfect square. So we are going to look for that number, and that number would be taking the coefficient of x minus 7 over 5, okay, dividing it by 2 and squaring it. That's just a simple rule. So it becomes minus 7 over 5 times 1 over 2 all square, which is minus 7 over 10 all square. So we'll move on to the next stage, first by removing this side so that we can have space to solve further. Now our value becomes x squared minus 7 over 5x plus the value that must be added, which is minus 7 over 10 all square, is equal to 3 over 5 plus minus 7 over 10 all square. So it's added to both the left hand side and the right hand side. This becomes x minus 7 over 10 all raised to the power of 2, which is the perfect square, is equal to, on this other side we'll have 3 over 5 plus 49 over 100, because the square of minus 7 will give you 49 and the square of 10 will give you 100. So we have x minus 7 over 10 all raised to the power of 2 is equal to, let's look for the LCM here. You have 100 into 5, 20 times 3, 60, plus 100 into 101 times 49, 49. We'll take this out again. So finally this becomes x minus 7 over 10 all square is equal to 109 over 100. Now if I take square across equal to, it will become x minus 7 over 10, okay, is equal to square root of 109 over 100. Now x, there's a plus or minus here, x here minus 7 over 10 becomes plus or minus square root of 109 over 10, because square root of 100 will give us 10. So I'll take this across equal to, and I'll have x is equal to 7 over 10 plus or minus square root of 109 over 10. If I also take this part away now, so this becomes x equal to 7 plus or minus square root of 109 over 10, common denominator. This becomes x equal to 7 plus square root of 109, which is 10.4 over 10, or x equal to 7 minus 10.4 over 10. And in this case we are having 17.4 over 10, while here we are having minus 3.4 over 10. So this will give us 1.74 or 0.34. So either way you have your answers here. 0.34. Let's see, this is supposed to be an equal to. So this is exactly what you are having in your final answer. 1.74 or minus 3 minus 0.34. We're given a question to solve, and the question is 4m square is equal to open bracket m plus 4 close bracket open bracket 2 minus m in a factored form. Here we're going to have a quadratic equation if we open up the bracket, but first it's not in our standard form, which makes it a bit difficult, but it can be solved. First is to open up the brackets. You have 4m square is equal to, use the first term here to multiply everything in this bracket. You have 2m minus m square, then plus 8 minus 4m. If I collect like terms, I have 4m square plus m square, because I take minus m square across equal to, is equal to 2m minus 4m plus 8. Now here I'm having 5m square is equal to minus 2m plus 8. That becomes 5m square is equal to, that becomes, if I take minus 2m across equal to, I have plus 2m, take plus 8 minus 8 is equal to 0. So you have 0 left on this other side. Now the equation is in standard form. We can go ahead to use the steps. Step 1 is to reduce the leading coefficient to 1. So you have 5m square plus 2m minus 8 is equal to 0, and I'll divide all through by the leading coefficient, which is 5, and here also 5. So in that case I will have this 5 will cancel out this. I'll have m square plus 2m over 5 minus 8 over 5 is equal to 0. Now step 2 says to equate the variable to the constant. That gives me m square plus 2m over 5 is equal to 8 over 5. So it's equated to the constant now. And we'll go with step 3, which is to find a number that will make the variable function a perfect square. Now that number will be the coefficient of my m divided by 2 times raised to the power 2. So you have 2 over 5 divided by 2 all raised to the power of 2, and that is equal to 2 times 1 over 5 times 2 all raised to the power of 2, and that is 2 over 10 all raised to the power of 2. So this is the number that I will add to my variable function to make it a perfect square. Now I'll continue here, but first by removing this aspect so I can have enough space to solve. That will give me my new equation as m square plus 2m over 5 plus 2 over 10 all square is equal to 8 over 5 plus 2 over 10 all square. If I factorize this, I'm going to have m plus 2 over 10 all square is equal to 8 over 5 plus 2 square over 10 square, and that gives me m plus 2 over 10 all raised to the power 2 is equal to 8 over 5 plus 4 over 100. Alright, you manage that. So I have m plus 2 over 10. Okay, all square is equal to, let me see if I'm able to solve this. I'll have 100 into 5 times 8, that will be 160, plus 100 into 100 times 4. So if I want to solve further and decide to remove this other portion, please always write as fast as you can. And now I'm going to have m plus 2 over 10 all square is equal to 164 over 100, and that is going to give me m plus 2 over 10 is equal to square root plus or minus 164 over 100, and that will give me m plus 2 over 10 plus or minus equal to plus or minus square root of 164 over square root of 100, and that's 10. So you have m plus 2 over 10 is equal to plus or minus square root of 164 over 10. Now if I take this across equal to, I'll have m is equal to minus 2 over 10 plus or minus square root of 164 over 10. And let me go this other way. What this will give is m is equal to minus 2 over 10 plus minus 12.8 over 10, and that becomes m is equal to, take a common denominator, minus 2 plus 12.8, or m is equal to minus 2 minus 12.8 over a common denominator, which is 10. Now in this case I'm going to have 10.8 over 10, and in this case I'm going to have minus 14.8 over 10. My final answer here will be 1.08, or my final answer here will be 1.48 or minus. These are my two final answers. Here we'll be looking at quadratic equation by quadratic formula. First, we have to know the standard form for quadratic equation. You have to have your question expressed in the form of a x raised to power 2 plus b x raised to power 1 or something plus c is equal to 0. And this is the standard form for a quadratic equation. And it is only when you have expressed your quadratic equation in this form that the formula can be applied. The formula says x is equal to minus b plus or minus square root of b square minus 4ac. Everything here divides 2a. Now this formula is also called almighty formula. The reason is because there is nothing in quadratic equation that the formula cannot solve. You know, usually quadratic equation that cannot be factored. that can be solved using factorization method is being solved using method of completing the square. But aka solves everything. It's a formula actually derived from method of completing the square, so you can use it to solve all form of quadratic equation so long as it is expressed in this form. Now our value for a is the coefficient of x square. We'll say the coefficient of x square, b is the coefficient of x, and c is the constant, which is all equated to 0. We'll take a simple example and see how the formula works. Now let me take an example. I may have example 1. Supposing I have a quadratic equation of this form: 2x squared minus 4x minus 3 is equal to 0. The quadratic equation is already expressed in the standard form. So a here is equal to 2, b here is equal to minus 4, c here is equal to minus 3. Take note that whatever value you take, the sign should be taken along, and the sign is what precedes the value. So I'm going to introduce this to my formula, which says x is equal to minus b plus or minus square root of b squared minus 4ac, everything here over 2a. And that's going to give me x is equal to, what is my b, minus bracket minus 4 plus or minus square root of minus 4 square, that's b, minus 4 bracket a, which is 2, c, which is minus 3. So everything here divides 2 bracket 2, which is 2a. Now I'll take my solvings down here. Minus 4 will give me plus 4, which is 4 plus or minus square root of minus 4 square will give us 16. Minus 4, this minus 4, this minus belongs to this. So you have minus 4 times 2. Or sometimes you could just put the minus sign here and multiply everything out here. 4 times 2, 8. 8 times minus 3 will be minus 24. Everything divided by 2 times 2, which is 4. But let me just leave it at 2 times 2 for now. So 4 plus or minus square root of 16. Now minus minus, whenever two signs come together in this manner, whenever they are all fused together, you resolve it to 1. And remember, there's always a bracket sign separating the signs, so it means minus times minus, which is plus. So here becomes plus 24. Everything here divided by 4. So I'm going to have 4 plus or minus square root of 16 plus 24 is giving me 40. Everything here over 4. Here I don't have much space, but I would delete one of these. Alright, here I'm going to have 4 plus or minus square root of 40, which is 6.324. Well, I'll take it as 6.32 to 2 decimal places, all over 4. And that becomes 4 plus 6.32 over 4, or you have 4 minus 6.32 over 4. Now if I take this one here, it's going to give me 10.32 over 4, or, and here will be minus 2.32 over 4. For this value, I'll get 2.58, or for this value I'll get minus 0.58. So 2.58 or minus 0.58 is our answer. We'll take another example here. Let's say this example 2, and it says 11x squared minus 9x minus 5 is equal to 0. Now this quadratic equation is in a standard form, so I'll just identify my coefficients: a to be 11, b to be minus 9, c to be minus 5. Then I'll put them in my formula, which says x equal to minus b plus minus square root of b square minus 4ac all over 2a. Now that becomes x is equal to minus bracket minus 9 plus or minus square root of minus 9 all square minus 4 bracket 11 bracket c, which is 5 or minus 5. Okay, everything divide by 2 bracket 11, that's 2a. Take note, this is covering everything here. So I'll have this to be equal to minus 9 is 9 again, plus or minus square root of, let's see, minus 9 square will give us 81, minus 4 times 11 is 44, 44 times 5 will be 220. Okay, that's minus 220. You have minus 5 there, and everything here divide by 22, so it becomes 9 plus or minus square root of 81 plus 220 all divide by 22, and I'll be having 9 plus or minus square root of 301 everything over 22. Now I may like to finish up here, so I'll need to remove this whole thing here. Okay, so this will become 9 plus or minus square root of 301 will give us 17.35, the point here, all over 22. So I'm having 9 plus 17.35 over 22, or 9 minus 17.35 over 22. So I'm having 26.35 over 22, or 1917 will give us minus 8.35 over 22. Now the value here will give me 1.197, which is approximately 1.198, or minus 0.380. So this is what you're having in your final answer, this and this. Here we are having example 3 as m minus 3 all in bracket raised to power 2. That's a perfect square, more like is equal to 1 to 1. Here it's not in a standard form yet, so we have to expand m minus 3 all raised to power 2 is the same as m minus 3 all brackets m minus 3, and that will give us m square minus 3m minus 3m plus 9, and this is the same as saying m square minus 6m plus 9. So in place of this, we will say m square minus 6m plus 9 is equal to 1 to 1. Now if we take this across, because we have to set everything to be equal to 0, you have m square minus 6m plus 9 minus 1 to 1 is equal to 0. So m square minus 6m minus 112 is equal to 0. It's been expressed in the standard form of the quadratic equation here. Now we'll take our value. A here is equal to 1 because the coefficient of m here is 1. B here is equal to minus 6, and C here is equal to minus 112. Now again, if I put it in the formula, x is equal to minus b plus or minus square root of b square minus 4ac all over 2a. I'm going to get x is equal to minus 6 plus or minus square root of minus 6 all square minus 4 brackets a, which is 1, then minus 112. I don't have a space. Everything here divide by 2 brackets 1. Now I'm going to continue with this by quickly removing this so that I can have space to solve. I'm going to have minus 6 will give me 6 plus or minus square root of minus 6 squared is 36 minus 4 times 1 times 112 minus 112 will give us minus 4 times 2 448. Everything divide by 2. So here I will have my new expression to be 6 plus or minus square root of 36 plus 448 all divide by 2, which will become 6 plus or minus square root of 36 plus 448. Let me quickly do the small maths here. 448 36. This plus this is 14, write down 4 carry 1. This plus this 7 plus 1 8, 484. So you have 484 all divide by 2, and this will become 6 plus square root of 424 will be 22, because square root of 484 is 22 all over 2, or 6 minus 22 all over 2. Remember, it is plus or minus. So for this value, okay, let me quickly just represent this way. For this value, I'm going to get 28 over 2, and for this value I'm going to get minus 16 over 2, and this will further give me 14 as my final answer, and this will further give me minus 8 as my final answer. So you have 14 or minus 8 as our final answer.
This one is for world peace. Let's live together. When two become as one, the bond is there to stay. Then think of when that bond joins more, it blows away. The mind that can conceive the truth and will believe the power of the one. are